Good evening, everyone. Welcome to Grow Up Online Tuitions and welcome to the class of Revision Your Concepts through Previous Year Question Papers. As in this series, we are going to discuss about the concepts by using of previous year question papers. By this, we can simultaneously revise revision of important concepts as well as previous year question paper. This was very important for both NEET and IIT students. I hope this series is very useful to you. Now let us try to understand these videos are daily uploaded. I hope these videos are very useful to you. Today's lecture, we are going to discuss about the two important topics. Those are Now let us try to understand the given question here. In the following given reaction, what is the A? You have to find out the A major product. You have to find out the A major product. By by solving of this question, we can revise the two concepts. You have to know the two concepts. The first one is Markovnikov's rule. The first one is Markovnikov's rule. To solve this question, you have to know the what does meant by Markovnikov's rule. And second concept is ring expansion. The second concept is ring expansion. Okay, before going to discuss the mechanism of this reaction, now let us try to understand these two concepts to solve this question. By knowing of these two concepts, that means Markovnikov's rule and ring expansion, you can easily attempt the given question. I hope all of you know the Markovnikov's rule. Now let us try to understand in brief manner. Markovnikov's rule. Okay, when an double bond is present in unsymmetrical manner. Now let us to explain this concept by taking example here CH3 bond CH double bond CH2. We have observed that here unsymmetrical. That means the double bond here, for example, if you pass a plane through this, these two sides are different. This type of compounds, type of double bonds are called this type of double bonds are called as an unsymmetrical alkanes. When there is unsymmetrical alkanes obtained, we use the two rules, Markovnikov's rule and anti-Markovnikov's rule. Depending upon the conditions, we use the Markovnikov's or whether Markovnikov's rule or anti-Markovnikov's rule. Here, the condition is HBr. Whether anti-Markovnikov's, if there is UV light or UV light is present, then we use the anti-Markovnikov's rule. Here, just HBr is present. Here, H plus and Br minus. Two products are possibility. For example, if this double bond is shifted towards this side, minus and positive charge. Assume this double bond is shifted towards this side, a negative charge and positive charge. This is the path A and consider this is the path B. Now let us try to understand what will happen in path 1. This is the path A. This is the path A product and this will be the path B product. Okay, so here double bond is shifted towards the right hand side CH3, CH positive charge bond CH2 minus charge. Here we observe that we know that carbocations order stability order is tertiary carbocation is greater than secondary carbocation is greater than primary carbocation is greater than CH3 positive. By this order here secondary this carbocation is secondary carbocation. This will reacted with H plus and Br minus. H plus is reacted here and Br minus attack on secondary carbocation. So the product will be CH3 bond CH bond CH bond Br. Here CH bond Br bond CH3. Why? Because CH2 reacted with the CH, it becomes CH3. Okay, this is the, according to Markovnikov's rule, we consider this is the major product. Why? Because this product is obtained from a highly stable secondary carbocation. Highly stable secondary carbocation. That's why this compound is a major product according to Markovnikov's rule. Now let us try to understand the part B. The path B mechanism, the path B products will be here CH3 bond CH minus bond CH2 positive. Here we observe that this carbocation is primary carbocation. This will react with HBr. This will react with HBr, produces the CH3, CH2, bond CH2, bond Br. This is the minor product. Why? Because the product formed from his primary carbocation, which is less stable than the secondary carbocation. This is that's why the first one is major product and second one is minor product. I hope Markovnikov's rule is clear to you. Uh, Now let us try to understand the what is meant by ring expansion. Now let us try to understand what is meant by ring expansion. The ring expansion is nothing but we know that when the ring is small, the more strain present on the ring. For example, here triangle type here this will be cyclo here is the cyclobutane. Here this will be the cyclopropane. This will be the cyclopropane, and this will consider as the cyclopentane, and this will be considered as the cyclohexane. This will be considered as the cyclopentane, and this will consider as the cyclohexane. So among the four structures we observe that here the ring is small, thus more strain. The ring is small, more strain is present on that ring. So that ring wants to be expands. So but in a higher expansion, less strain is present. That means more stable. Here ring is high, that means number of carbons present in that ring is high. It is it undergoes the less strain, that means more stability. Here more strain is present. Okay, so the ring expansion, which means, for example, okay, now let us try to understand how ring expansion takes place in a given reaction. I hope this concept is is clear to you. I hope first one, Markovnikov's rule and the ring expansions, what does meant by ring expansion from uh, cyclopropane to cyclobutane. Here we observe that ring expansion takes place. How? Here we observe that in the cyclopropane, three carbons are present. Okay, three carbons. In cyclopropane, four carbons are present. The ring strain will be the ring strain decreases, that means more stability as well as ring expansion. Here cyclopropane to cyclobutane. This is all about the ring expansion. Now let us try to understand the mechanism of the given concept, given question, today's question. I hope this concept is clear to you. Markovnikov's rule and what is meant by ring expansion. Now let us try to understand the today's question mechanism. I hope these two concepts are clear to you. Now let us try to solve this question. Okay, by itself you can solve this. Here, for example, here also two possibilities. CH2 bond CH3. This will react with HBr. Okay, consider this is path A and consider this is path B. Here also reacted with HBr. Okay, now let us try to understand the complete mechanism of path A and path B and try to figure out which one is the most stable product. Okay, for example, if this double bond is shifted towards this side, here CH2 and the positive charge is present. Okay, bond C, bond CH2 minus bond CH3, bond positive charge. Here we observe that this positive charge we call it as carbocation. Here the formed carbocation we observe that this is the tertiary carbocation. Here the formed carbocation is tertiary carbocation. We know that the order of stability of carbocations, order of stability of carbocations. Order of stability of carbocations. Order is tertiary carbocation is highly stable, then secondary carbocation, then primary carbocation, then CH3 plus. So we conclude that path one obtains the major product. Okay. So for example, okay, here carbocation having the positive charge, here Br minus and H plus. This CH3, Br minus attacks on this C plus. The product will be, the product formed here is bond C bond Br bond CH3 bond CH2 minus. Okay, for example, we previously discussed that less number of, that means a cyclobutane which is having the high strain, that's why this bond is shifted towards this side. This is having the, sorry, due to the presence of high strain on cyclobutane, this bond is shifted towards this side. This bond is shifted towards this side. This is having the negative charge, this is having the positive charge. So here negative and positive form a bond. So without any confusion, now let us number these compounds. Here this is the number 1, and this is the, this negative charge is the number 2, and this will be number 3, and this will be number 4, 5 and 6. So the six membered which we discussed previously is the less strain. Less strain, that means more stable compound is produced. Here CH2. So at the first position, now let us consider this is the first position. We have the Br and CH3 group is attached to this first carbon. Okay, here is the number 1, 2, 3, 4, 5, 6. 6. I hope this concept is clear to you. Adjacent to the sorry, adjacent to the sixth position, that means the first position we have the first carbon is attached with bromine and CH3. Bromine and CH3, the less strain product, that means cyclohexane, substituted cyclohexane is produced. Substituted cyclohexane. Substituted cyclohexane is formed. So we previously concluded that why because of tertiary carbocation is formed. That's why this path is we previously concluded as a primary product. Okay, I hope there is no need for the path B. I am requesting everyone to please go with the path B also. Why? Because variant different product is formed. Now let us try to draw the mechanism of the path B yourself. I hope today's concept is clear to you. That means Markovnikov's rule and ring expansion. So our answer will be the second one. So our answer will be the second one. So I hope this series, the revision of concepts through previous year question paper, previous year questions paper series is very useful to you. And please do subscribe for more videos and updates. And please share with your friends and family members. And please share the this series is going on Grow Up Online Tuitions. Thank you and all the best. If you have any doubt, please comment below or directly WhatsApp to us. If you have any problem, please call to me for the preparation of NEET and IIT, how to manage NEET and IIT timetable, study timetable. I will help you, definitely help you. Thank you and all the best.